hammer them, unless it's something that's extremely could end up in, a serious injury, fatality, whatnot. And I've never been directly associated with fatalities. I never want to be. I have been involved in some serious injuries and some, accident investigations that were really big, big issues. So, today we've got respiratory, some H2S, some other hazards or anything. And I always like to start off how I train or how I do safety meetings. I'm a very informal guy. Okay. I like questions. I like to bounce things around, relaxed. Um, and I've had meetings where I've had guys, everybody in suits, and I tell them the same thing. Hey, let's just all interact. Let's have a good time, right? Because a lot of times when you're discussing this stuff, oh geez, safety meeting, right? That's, they're going to feed me good, but it's a safety meeting. So we'll start with respiratory and a couple things. Has anybody been ever had to wear respirators or been in confined spaces or have had to deal with an atmosphere, mists, vapors, combustible dusts, anything like that, silica? How many people? Just throw your hands up there so I can see who you are. Okay. Confined spaces? You? Who else? In the back? See? You're in the back, man. So we all know that, there's some nasty atmospheres that you can be in. And as far as with respirators, it's that lifeline for you, right? If you're in an atmosphere that could put you at serious risk. There's several types of respirators. Okay. You've got, your half, your full face, supplied air, things like that. And I've had folks that biggest thing is they wear the wrong respirator. Okay. You go into an environment where you've got mists. Okay. And they'll throw an N95 dust mask on. The filters are dust masks, not the actual dust mask. But the rubber seal, the full face with the canisters. And I'll say to them, okay, hey, we're going into this, you guys are going into this chemical area. It's a confined space. We've tested it. We've got a lot of, hazards. You guys have the right respirators on. Sure do. I've had a lot of people do this. Sure do. And I'll say, okay, well, let me see before you get into that atmosphere. Well, they've got dust cartridges on there. Here's the thing. That's to collect dust, right? If you go into an atmosphere where there's vapors, mists, anything that has moisture in it, what's going to happen is while I'm breathing, what those filters do is they're going to draw in the moisture, right? Saturate the filter. And in essence, you're going to get a major exposure to that. It's doing nothing to you. If anything, it's really going to affect you in a lot of different ways. So respirator wise, just trying, everybody, there's so many, it's like, which one do I do? So it's kind of like you get these little trainings like this that we're having, and basically, knowing the right respirator. Okay. You can go through the standard and talk about, it's OSHA, CFR, this and that, but real is what respirator for that job that you need to have. And some is supplied air. Okay. You got the full face, you've got SCBA, you may have a tank, you may have, there's escape bottles. And the one thing with an escape bottle, if you're in a confined space, whatever the atmosphere may be, a lot of times to get out of the space, okay, if something goes wrong, okay, there's an escape pack bottle, okay. That's not designed to put on and say, I'm going to go into that space and I'm going to do work, or I'm going to go in and I have to do an inspection. I'm going to look at whatever's inside of it. And you get stuck. Okay. You're in a vessel, you fall, you're stuck. Okay. It's a hazardous atmosphere. Okay. I'm stuck. I'm trying to get out. Maybe your supplied air bottle goes bad. The air runs out. Who knows? So you have an escape pack. That escape pack is only good 5 minutes, maybe a little under, give or take. So you got to know exactly how to turn that thing on, and that means I got to get out. Okay. Um, so if you're in a situation where, I got to get out of that area, that escape pack is specifically for getting out. So knowing about the respirators and what to wear and the several different kinds, and also like the dust mask, you guys all know the little white dust mask you can wear. Everybody calls it, hey, yeah, it's a dust mask. It's actually a respirator, believe it or not. It's got the same kind of filtration system in it that would be inside of a cartridge filtration system. It's just you don't get that seal. It's not for that really good extra protection. Respirators also, like I said, there's so many different kinds. And this PowerPoint's the awareness one. I'll have to see. I believe it does. They're in there. But getting a fit test. You have to have a fit test before you can actually wear a full face or a half face with the rubber seal. Different sizes. If you're going to be going into a hazardous atmosphere that requires you to wear a half face or a full face, okay, you have to be fit tested. And the fit test basically is you're going to try on different masks, one that, different sizes, one that's going to fit you. It's going to be like a positive air. Okay, you have to do all these tests, move your head up and down and things like that to make sure you get a good seal. Okay, because one thing, you don't want to just grab a mask in a hazardous atmosphere, put it on and say, well, I got a respirator, I'm good. Well, if you don't have a good seal based on the atmosphere, that does you no good. Okay, so you're medically cleared, you're fit tested for a respirator. And if you get fit tested on a half face, okay, you have to get tested on a full face. Okay, so both of those, because you never know the atmosphere you may end up being in. All right, let's try to go and see what we have here to the next slide. Okay, go ahead and go again. Okay, so some of the standard real quick, and I'm just going to try to run through it and we'll keep going here. General industry, part 1910. Okay, as far how OSHA looks at it, 1910 is your general industry. Okay, shipyards, which 9 times out of 10, we don't train a lot on that. Terminals, maritime, longshoring, and construction, 1926. So the majority of what usually the bulk of what safety training is over is usually your 1926 and your 1910. That's usually the big thing with that. So some of this here, permissible practices, your definition, a respirator program. You have to have a respirator program, right? Selection, which we talked about, selection of respirator. What type do I need? You have to make that determination before somebody goes into a confined space or goes into a specific building or whatever where a hazardous atmosphere may be there. Okay. Your medical eval, you got to have a medical eval prior to testing. Okay. Make sure that, you can breathe with no complications with how that respirator is going to fit. Your fit testing is you have qualitative and quantitative. Some are, you get hooked up to a machine. It goes through the air. What you do is you get fitted, you move your head right, your right or left, right, left, up, down. And they usually want you to take a deep breath. Okay. That's if you're getting tested with the forced air. Just to basically see if you've got a leak around the seal. Okay. Another test that they can do also is, I don't know if anybody's ever seen it, where you break off and it's got like the little bit of smoke that comes out. You put your respirator on and you they go around, the mask, the seal. And if you can smell the smoke, then, we got to readjust it. That's not the most effective. It used to be used years ago. There's also where you put a hood on, almost looks like a space hood. You have your respirator on, put the hood over, and what they do is like a banana oil, they shoot it into the front face. And as you move your head left, right, up, down, if you can smell or taste that, then we know that we don't have a good seal and we have to readjust that respirator. Maintenance and care on respirators. That's a really big deal too. Especially when you have a half or a full face, okay? Anything that requires you to get fit tested. A regular dust mask, you don't have to be fit tested, even though it is in the respirator family. So the maintenance and care, that's key, okay? If that is what is that's what's going to help you protect you from, okay, potential serious lung issue. Pray to God it never would be a fatality or anything of that nature. Maintenance and care, especially with that rubber seal, you need to clean it. They say you can use soap, water, and clean that seal if it's something that you use all the time. Because what I've seen a lot of times is I've been on jobs, sites, or wherever, and it's, respirators are needed. And I've seen guys where they'll use it. Okay, they'll use it for who knows how long. Throw it in the back of the truck. Okay. What happens here in the great state of Ohio and other places? Rain, sun. Okay. So what can happen with that? It's going to get dry, right? It's going to start to crack, things like this. So basically, if you don't take care of it, I mean, that's going to not protect you anymore, plain and simple. Always put those in the bag that it comes with. Okay. You always want to make sure that thing is clean and in good condition. Another thing too, that's kind of something that a lot of folks don't really understand, and it is those ones with the canisters on them. Okay. Now, some are for the vapors, mist, and some are just for your dust, particulates, things like that. I've had people where they've had them on for months. Okay. And they work in a hazardous atmosphere. We'll use dust for an example. Silos, where there's, any kind of powder, corn, things like that, just an example, where there's accumulation of a lot of dust. Man, I don't know why I go in there and I'm using it and I'm having a hard time breathing. When's the last time you changed the filters in that? Oh, a couple months ago. There you go. Okay, they're only good for so long. I don't know if it's that people see them and it looks high tech and everything, and it can be used forever. It can't. Those need to be changed. And I always say this: if you have it on and you start to feel that you're not really getting good air, that's probably time that you need to take those off and put new ones on. Use your, people have to use their own discretion with that stuff. That's part of taking care of it. I look at it like this: if that's going to be my line of defense to protect me from a hazardous atmosphere, you betcha I'm going to make sure I take care of that, right? That's definitely something I want to make sure I'm going to take care of. So maintenance and care, big deal, right? So we've got how we do our testing. Okay. You have to be medical eval, fit testing. Okay. Maintenance and care. And if it is bad, turn it in, get another one. Pretty much all companies are going to do that for you. Breathing and quality use kind of throws in with what I was talking about with the filter system. Identification of the filters, the N95, the P100s, different kinds. And, for whatever the atmosphere is. Some are for the particulates, like I said, N95s, P100s. A lot of them will say that on there, the type of filter that you need with the atmosphere that you may be, involved in. Training, program eval, record keeping. If you use respirators a lot of companies have to keep a good record keeping of that. What they use, what it's for, that they have a program, people were fit tested correctly. It actually shows, well, what is the kind of testing that you put your folks through? Okay. You got to have that. For the simple fact is, I want to know what we're using and everything is according to how it should look, how it needs to be. We've done our due diligence. We've taken and we've put it all together. And another thing too is, as far as on the record keeping side of it, I've seen OSHA before come into a facility and they say, I'm here for your record keeping. Okay, I'm here. I want to see your respiratory, respiratory fit testing program. And they can ask for that, and they can literally, hey, give it to me. They can sit down, they can look through it, see if you're following, you're doing everything you're supposed to do. So, it's kind of like on that side of it too, got to have good programs in place. Okay. So user seal checks, which we talked about, right? Cleaning, medical questionnaire, information, employees wearing respirators when not required under the standard. Okay. You can click on the next one there. Go ahead and go to the next one. Go again. Exposure concentration airborne contaminants would occur if the employee were not using respiratory protection, right? You could get it's as simple as that. Okay, go ahead and go again. Okay, here's what I was kind of talking about with the masks. You got the quarter mask, which is basically kind of over the nose. You've got your half mask. There's the canisters I was talking about. There's your half mask that is a fitted mask. You would have to go through your respirator fit testing. Okay. Here would be your full face. There's still canisters on that. Okay. You've got your full face, which gives you the eye protection. Okay. And then mouthpiece, nose clamp. Okay. This here, you don't have to have a requirement, no fit testing required for that one. So basically it's, you pick the category. You can go to the next one. Whatever your facility, okay, is required or what the company requires. So here's the hood. There's a helmet, loose fitting, face piece, full body suit. Okay, so a lot of times based on what environment you are in, there's also extra PPE that you may need to wear along with if it's forced air or filtering air. Like a paper dust mask? Oh, like that, no, no, no. You know what I mean? The white dust mask type thing versus that. Yeah, yeah. Yes. Yes. It's covered under the respirator standard. Only because a lot of people, oh, here's this dust mask, it's limited protection, obviously. But yes, it does fall under the respirator standard. Air purifying, which basically we know that it's going to get the contaminants out. Okay, you can go ahead. Here's your air pack. It's going to be your forced air. Okay, there's the other one where basically it's just showing the different canisters that you have to put on for the environment that you may be in. Okay. There we go. Negative pressure particulate respirator with filter, okay, integral part of the face piece, okay, or with through air purifying element. Okay. I don't want to spend a lot of time on all this because this slide is crazy big and we're just kind of doing a safety meeting. So I'll kind of get you through some of the little things that you can look at. Another thing too is to get fit tested. No facial hair. I've had guys with full beards on a job site and I've come in and said, okay, we're going to do your respirator fit testing. Go in. Okay, I'm ready. Well, no, we can't do it. Why is that? Because you got a full beard. You got to shave for me to do it. I've had guys lose their mind over that. I'm not shaving. I'm not doing it. I'm not shaving my goatee. I refuse to do it. Okay, well, let's figure something out, which we can. This hood right here, which is almost like a half kind of hard hat with a flip down. When it flips down, it comes underneath here and it seals. Okay. And basically, this machine turns on. What it's doing is it's pulling air in and it's a filtration system. So I've had guys and I've told them, okay, well, here's the deal. I can set you up. You don't have to shave, but you're going to have a nice big hood. It's going to come down here. It's going to seal. It's about like this. You're going to have to wear a pack on your belt. It's got a hose that comes up. If that beard's that important to you, I can fix you right up. So there's times that we've had to go to that as well. You would be you would be very surprised that guys are so, and really don't want to get rid of that. I mean, that's what it is, right? Okay, you can go to the next one. Okay, you can go to the next one. See where we're at. Continuous flow. So you got a continuous flow of air, continuous flow of breathing air, respiratory inlet covering. So you've got that continuous flow of pushed air. Okay, demand, basically it admits the breathing to air to the face piece only. So it's only concentrated here. It's not like you're wearing a full suit, okay, and it's protected and it's forcing air in, okay, to not only help you breathe, but keep the body cool as well. There's so many different kinds and so many different, I mean, they've come a long way. They've come a long way with respiratory. Okay. 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 The supplying respirator. All right. So basically what this is where he's almost got a hazmat kind of atmosphere, right? You're going to have a Tyvek, or you're going to have some type of a rubber suit on, a space suit, with full protection, with nitrile gloves, something. This guy's probably working in a chemical atmosphere, okay? Which means he's going to have, there's going to be tanks that could be at the end of the room, okay? O2 tanks, and it's got a line that's so many feet that hooks in, okay? So that allows you to move around, conduct the work, okay? But you are relying on. This is where the rescue pack comes into place. A lot of times that small bottle can be connected onto your hip if you're in that style of atmosphere. So if that hose would get cut, if something would happen, damage to it, okay, think about this. If that happened, are you gonna panic a little bit? You can't breathe, you're gonna panic, right? Oh man, you can't get your breath. You're gonna start, panicking, and that's when other hazards and things can happen. So what you do is basically on that pack, switch the bottle over. It's got another extension into the hose. So turn it on, it'll give you the air. And that, once again, is what? That's meant for you to get out of that area, that escape bottle, okay? Now, you can't just kind of mosey on out of there. You got to go, okay? If it comes to that, you got to go. Okay. And then there's the SCBAs, which is the actual tank, kind of like the fire department, same thing. Okay, that's got your air in the back, which is supplying you with the air. You definitely have, and anything that you're going to see, go ahead and go back to that again. Oh. Okay, like here. When you see this here, this is pretty much a hazardous atmosphere to where you have to, you're getting all the PP that's necessary. I mean, you're going into an area where major skin irritation, burns, acid, caustics, things like that. When you're into this type of PPE, you're into some pretty bad stuff, okay? All right. Here's just the other one I was telling you about. Here's this escape pack. Some of them look different, like these bottles used for emergency evac, right? Just enough for you to get out. Okay. Okay. There's our written program under the respirator program, specific procedures based on the type that you're going to need with the atmosphere that you're working in. Got to update. So if there's changes throughout with what your specific, this is the job that we have that we've done for years, and it requires a half face. Okay. Now there's a change in the process, or, we're getting involved with a different company and we're doing a lot of that work. So then you're going to go in and that's going to change, right? You got to stay up. You got to change that program around. Okay. A program administrator, basically it's the person who is responsible, right, for that program. Okay. You got to provide the training on basically how to wear a respirator the proper way, how to actually put it on, take it off. Putting it on a lot of times can be a real pain. You know, a lot of times it has to be loose. You want to bend over, put it against your face, and then put it on and tighten it up. Okay. So you got to have training on how to do it. Remember the medical evals, got to have medical eval. Then you would do your actually fit testing, fit and everything to you. Employer obviously has to provide, pay for and provide. It falls under the PPE standard as far as if it's something that you would have to have because you're dealing with that environment. Okay. Once again, it's more into the written program. You can go ahead. Go ahead. Selection, medical eval, fit testing, use, maintenance, breathing, training program. That's pretty much what's all going to be in your program that is going to be you know, your program based on what you do, your written program. This would kind of all be involved in that. You can go ahead. The employer has to select, once again, the environment. There we go. That's most common used, right? For just a basic, you know, little bit of dust and things like that. Most commonly used. Okay. Here's your full face. Okay. This is designed. There's two different kinds. This one isn't designed to actually put forced air into it. You can see it has the filter cans on it, right? So if you're getting into 9 times out of 10 a hazard that requires you to wear the full face, you're probably going to be in more of an area of aerosols, painting, things like that. We have a company, Sherwin-Williams, that we have in Massillon, and obviously it's paint. Okay, it's very strong when you're in there, and you don't have to have the respirator on, but they have a clip that has to be on your side. Okay, so obviously if there's some type of a release or whatever, you've got that availability to hurry up and put that on, and it's a half face. For you to carry it, one thing is that they want to see your medical evals. They want to see your written program. So then they know, okay, you're covered, your company, you've done what you need to do to be able to work in that facility. Chemical plants. I've been in several different chemical plants with some real nasty stuff. And they've basically what it is it's almost like an escape pack, like I was telling you guys. But what it is, it's actually filters fresh breathing air. So if there is, you know, an emergency happens and it's evacuation, that basically is for you to put on to get to a muster area to exit the facility and get out. Okay. NIOSH. Basically, NIOSH is they kind of set up, they don't really enforce like standards like OSHA does, but what they do is they certify the stuff. Okay. So they'll certify that respirator. Okay. That specific 3M is certified. Okay. All right. Okay. Okay, so we're looking at our IDLH, immediately dangerous to life or health. Okay, so basically what it says, an atmosphere that poses immediate threat to life would or cause irreversible adverse health effects and would impair the individual's ability to escape a hazardous atmosphere. So we know based on this is what the atmosphere that we're in an IDLH atmosphere. Okay, we know that we're going to have to make an assessment on what it is. We know it's IDLH. What choice of respirator do we need for, you know, an immediately dangerous to life or health? We get that, that's a bad atmosphere, right? So we're probably not going to throw on a dust mask. Okay. We're going to need to know this is exactly what we need. This is what the customer requires. Okay. We now at that point, we probably need to change, right, in our program. Okay. All right, so if you look at this in atmosphere oxygen content below 19.5, okay, volume, all oxygen deficient atmospheres are considered an IDLH. There are some atmospheres where it can actually displace oxygen, right? Depending on where you're at, it can take away oxygen, okay, whatever the atmosphere is. You go into a confined space, you have a 5 or 4 gas meter, okay? That meter has to have a calibration done on it and a bump test every day before you go in. Is anybody familiar with those? With a 5, 4 gas meter, what I'm talking about? That's usually designed for any confined space. Now that could be vault, vessel, anything that would be classified as a confined space. And on that meter, it'll have your oxygen, your CO, your H2S. Usually it's the 4 big ones, okay? And they're set up to where the range is 20.8 is where you want to be. That's good oxygen, okay, efficiency. If they fall under a 19.5 volume, you still get a play with the ranges. Those are set up, those meters, to if it goes off in an atmosphere, you still have plenty of time when it goes off, it alarms for you to get out of the space. So basically it's set up to where it's picking up what it is while you're in that space to do an inspection, or you're looking at something, or it's guys working in there. That's basically helping you, a piece of equipment that's going to detect if there's a hazardous atmosphere that you're in, okay? And there's numbers that are associated with it. So anything that's oxygen deficient, right? If it's deficient, immediately dangerous to life and health. There could be other things, specific respirator that we have to wear, okay? Could be forced ventilation, okay? To help with air movement so we don't lose, we don't get into an IDLA atmosphere, okay? So if we're looking at some respirators for an IDLH, okay? Full face pressure demand, SCBA, NIOSH, when I told you about NIOSH, minimum service life of 30 minutes. Okay. So if we are in an IDLH atmosphere, this would make sense, right? Immediately dangerous to life and health. Okay. The full face with pressure, once again, there's his escape pack. Okay. So he may have supplied air you could see going here. Okay. But it's not actually going into this tank. This would be his escape pack, how it goes across here to get out. Okay. You can go ahead. You can go again. Okay. Yeah. Here we were talking about saturation, right? Dust, different types. This here actually indicates it's orange for safe, brown for discard. Some of them come like that. Remember when I was talking about, guys are saying, man, I'm having a hard time breathing, Well, you probably need to change those filtration system on the can for the half face and full face. Remember, those can be either for vapors, fumes, mists, or dusts, okay? Some of them will have an indicator that orange, okay, I'm still good, okay? I can still get some use out of it. Okay, as soon as it goes brown or whatever, you want to discard that, I can't, I'm not going to use this. And I always tell guys, gals, use your discretion. If you're in an area where you constantly, you have to, this is being used all the time and you rely on this, you want to take probably really good care of that with filters and the masks and everything. And then you have this one over here, which is the filter for the side. This one also has a flap on it you can pull over, like almost like a sticker. And it'll indicate how bad the respirator filtration system is and when it needs to be taken out of service. Not all of them have it though, but mostly all of these do. Okay. 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 Oil particulates are present. Okay. So we know that if we're going to have any type of, an oil, liquidy, something that gives off a mist, we're going to follow that manufacturer respirator for the environment that we're going to be in. Okay. Like I said, there's specific types, the environment that you're in. Okay. That needs to be an evaluation. When you evaluated that, you have your written program. Okay. Okay, go ahead. Filtration at least 99.97%. And some of these numbers are, kind of give and take and everything. Then you kind of get into the particulates, 0.3 micrometers. Now we start kind of getting into a little the chemistry whole thing and all that, which we're not going to do that. You can go ahead. Supplied air, which I talked about that, and equipped HEPA filter system. There's NIOSH again. And NIOSH is going to say, okay, HEPA filters, we've certified them, and then they're going to say what they're under. CFR Part 11. CFR Code of Federal Regulations is in the OSHA manual, okay? So it could either be 1910 or 1926. So that's what that looks like there. Our air purifying, equipped with any filter certified particulates, once we see NIOSH again, and our contaminants, okay? Then we come back here to our at least 2 micrometers. Biggest thing I always tell everybody is see the environment that you're in, good evaluation, good written program, okay, good medical eval, and a good solid fit test, okay? And then you will choose the specific respirator for that environment, okay? You can go ahead. You can go ahead. You can go ahead. Annually, there has to be a review, okay? So annually, you need to get, retested again. For that, you can go ahead. Let's see, go ahead. Qualitative, the pass or fail basically relies on individual response to the test agent. Here's that agent I was telling you about. And this is the qualitative fit test. See where he has the smoke? He's got the respirator on. He's having him look up, down, right, left. Basically, you go around. It's the smoke. If you can taste it, then we know we don't have a good seal. Okay. Okay. All righty. And this basically just goes back into everything that I talked about. Style, size, make. You can go ahead. You can go ahead. Go ahead. Here's another thing too. Corrective lenses, goggles, other PP must be worn in a manner that does not interfere. So if you wear glasses, okay, you have a full face, okay, it could cause a problem with a full face, right? If it interferes, they do make specific ones if somebody has corrective lenses, okay? So they've come a long way. There's different styles and things like that can kind of help you out based on, you wear glasses, with contact. Basically, if I'm not wearing contacts, if I'm in an atmosphere where there's a lot of vapors, right? A lot of mists, because that could be bad, right? So you don't want to do that. Okay. Okay. All righty. User seal check. Hand in the front. Take a deep breath. Okay. If you get a good seal, you're not going to hear anything. Okay. That's basically once you've been fit tested, once you've done your eval, if you're going to go into that specific atmosphere, right? You put it on a quick test for yourself, go like that. So then you can tell if you have a good seal. Basically, this is because of the front piece, okay, with the kind he has on here. Same thing, but then what he's going to do is he's going to hold on to the filtration system and see if that works too. You're getting a good filtration. Okay. Okay. All right. Okay. 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 You can just keep going. Keep going. Keep going. Okay. I'm not going to continue with this because it's a long PowerPoint. Like I said, it would be a big expanding on if we had just a respirator training class. So we'll go ahead and we'll stop there. Does anybody have questions on respirators? We kind of hit on just basically different sizes and different styles and the atmospheres and things like that. I hope I can answer it.
So if you're not trained, and it's trained since you're put this on, say, well, I'm not trained. You repeat the question. So yeah, just if you're not trained, if you got trained.
Absolutely not. And a lot of times that's tough for people when it's a customer, right? But I look at it like this. If they're putting me in a situation to where, don't wear it, it's no big deal, you're just going in there for a minute, that kind of thing. Absolutely. No, I can't do that. You know, I'm not fit tested, or, you know, well, I'll just throw on that half face. It's no big deal. Just tighten it up. Absolutely no. Anything else? I know I kind of flew a little bit, but everybody's kind of gets the idea with the half face, the full face, supplied air, right? Basically trying to see which one for the atmosphere that we would need, a particulate and dust, different filter versus mists, okay, vapors, things like that. So there are, you know, the differences with that, medical eval, then the actual fit testing, right? And the different kinds of testing that you can go through based on the person that's evaluating you and putting you through the test. Okay. Any questions? You guys pretty much get it a little bit? Or are you just like, yeah, okay, come on, dude, let's move on, right? Okay. So that'd be respiratory. In our next one, because I'm kind of rambling, and it kind of all ties in. So I'll kind of go with, let's go back to the files again. Go to H2S awareness up here. Yep. Okay. Oh, okay, there we go. H2S. H2S is hydrogen sulfide. It smells like rotten eggs if you get exposed to it. Okay, it definitely is it lays very low in any kind of vault, vessel, any confined space, based on the specific atmosphere that you are going to go in. It's got a rotten egg smell. Okay, you're going to kind of notice that. If you do notice it, get out immediately. For the most part, it's going to be a monitored space, right? So we're going to go back to that 4-gas, 5-gas meter, right? It's going to detect H2S. And it's basically set up on parameters. If it gets to a specific number, okay, it's going to alarm, give you a chance to go ahead and get out of the space. H2S can be in low stagnant water in vessels. It can be caused by that. Sewage, wastewater, okay? Anything that's like that, where microorganisms, it's broken down, there's moisture, there's stagnant water, based on maybe whatever the product was, could have an effect on it. H2S is, if you don't get out of an area and H2S is present, okay, H2S can kill you like that, okay? And one thing with a confined space, we'll go to that. Okay, so I have an attendant. He's the guy that's monitoring the hole, right? Puts the wand down in. I've got another guy who's going into the space to do the work, okay? So I'm up here, I'm monitoring it and everything, and oh, I see that it's bad. That guy can get out. Flip side, Got two guys, they're going to go in and do maintenance. We don't have a monitor, no way to check out H2S if it's H2S, if it's CO, whatever it is. Two guys go in to do the work. You got a guy standing over top, he's looking down in, and this has happened. Okay, the one guy passes out, dead. The other guy, oh man, he's either going to help him or try to get out of the space, dead. There is a possibility that guy who's looking over, he could get it too. Okay, H2S, it's very low on the surface. Okay, so you've got that, you've got CO. Okay, it's heavier than air, H2S. Very, 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 very dangerous. I was on a job at a power plant, and it became a retrieval, not a rescue. Guy went down in this little vault, some kind of a storm water runoff, and goes down in. There's a guy on top, a boss, and there's another guy standing there. Guy goes down in, it's overcome with H2S, passes out. Okay. The other guy, oh man, he sees that something happened. What's your instinct? Go get him, right? He goes down in. That's two fatalities. The third guy, what's he gonna do? Oh man, I got two guys. Okay, I'm gonna call 911. I'm going in, right? What happens then? We got three fatalities now. That's how bad H2S is. Okay, you can go ahead and go through here. Extremely toxic gas. It is colorless. Okay. You can't see it. It is heavier than air, soluble in water, has a smell of the rotten eggs, which I discussed. It's a higher concentration of us, can be deadened your sense of smell. So we smell the rotten egg smell, right? We know it's H2S. You continue to maybe work in it or be around it, but it's not a heavy concentration. What ends up happening with H2S is you stop smelling it after a period of time. You don't smell the rotten egg smell and whatnot. So you continue to work, no big deal. So now you're going to start gradually getting the effects. Now, that's in an area where H2S could be mild, okay? So you kind of smell it. You're working in this, sewage system, and it's just bad. Then it kind of goes away. You're thinking to yourself, maybe, right, I've been working in this all day, man. I'm just getting immune to it. It's horrible. You can get overcome with it, and you could pass out. You could die. A couple things that it does: it slows down the heart rate, and I believe there's a couple things in here. Go ahead. It's naturally occurring, like I said, right, in stagnant water, things like that. Go ahead and go back, please. Let's see where we're at. Yeah. Produced by bacteria, decomposition, organic, right, matter. So compost, things like that. Believe it or not, farmers can get exposed to that. There's been a lot of deaths over that. Why? The obvious, right? Swamps, polluted areas. You ever been around stagnant water and it kind of smells? Yeah, we've all been around. You're like, man, that's terrible. There's H2S in that. Okay. I was talking about farming. There you go. There's the cow. Dairies, breweries. Whoever likes beer, right? H2S can be there, man, because of the vats, right? The vessels, what they use, how they go through the process of mixing. If you go down and you have to do work in those, and they do sometimes, right? Guys get called in, contractor going to repair it. They need to be on air, right? They need to have that respirator, need to be on air. Chemical processing, geothermal, fisheries, right? It's water. If there's bacteria in the water, that can happen, okay? It can be found also in oil, natural gas, well sites, big time. Refineries, big time, H2S, okay? That can be found. I've worked in a Marathon refinery in Canton, and they actually have H2S alarms throughout the plant. So I may not be just in that concentrated vessel, vault, tank, silo, whatnot, but it can be released in small amounts, okay, throughout the plant. Because you're dealing with fuels and crude and all kind of stuff, and it's sulfur basically. So these alarms that are all throughout, if they alarm, that's immediately to get to a muster area, right? Because if there's a major release, there's gonna be a lot of fatalities, okay? That's how bad that is, okay? Colorless, when they say odor, unpleasant odor, the rotten egg thing, you can go ahead. 10 parts per million, which would be your low concentration, okay? So if we're using that meter I was talking about in a space, remember, it's got your oxygen, it's got your CO, it's got your H2S, okay? Those are set up to where it all goes by parts per million. So at 10 parts per million beginning eye irritation, okay, those meters are set up to be at 5 parts per million, okay? So that's set off for that to go off to alert at 5. Why 5? That gives you a chance to get out, right? So at 10, you start to have some eye irritation. 15 or 50, excuse me, to 100, respiratory tract irritation after about an hour exposure to it. And at that point, you're probably not going to be smelling it as much. At 100, you're going to have coughing, loss of sense of smell. These are kind of the steps that it goes through. Irritation after several hours exposure, gradual increased severity of these symptoms, death may occur within 48 hours. And it all has to do with how much exposure you would get. 200 to 300, respiratory tract irritation. Then once we get to a 500 to 700 parts per million, now we're talking loss of consciousness, right? So that's a high level. Okay, we're looking at 1,000 to 2,000 unconscious immediately, okay? Unconscious, it depletes the air, right? It depletes the oxygen level. So once it gets to that point that there's no fresh air movement, there's no respirator used, it's immediate, death immediately. So it's very nasty, nasty stuff. Because like I said, it lays a lot lower, right? So if you're down and you're working in it, it's heavier than air, okay? You can go ahead. The weight of gas compared to air equals 1, H2S, okay, and 30 degrees, at 30 degrees at 1.18. 19% heavier than air. Okay, now we're getting into our chemistry facts and all this, but that's okay. Go ahead. Toxic, right? We talked about immediately dangerous to life and health. That's at 100 parts per million. A single breath of hydrogen sulfide at about 1,000 parts per million may paralyze the respiratory system. So if it paralyzes, you can go to a coma, you could pass out. OSHA's general industry PEL is 20 parts per million. Remember I was talking about the general industry standard and then the construction standard. General industry, the peak limit is at 50 parts per million, up to 10 minutes, if no other exposure during the shift. Now, how are you going to know about the parts per millions and everything like that if it's monitored, right? And that would be the 4 gas, 5 gas meter. Okay. Okay, lower explosive limit, it can be explosive, right? It is flammable. We talked about that. It'll automatically ignite at 500 degrees Fahrenheit. End of a lit cigarette, 14,000. So if we kind of look here where it could start, if we've got rich oxygen level, lower at 0%, okay. So with the H2S, where H2S comes from and where in our training, exposure symptoms, health effects of H2S, our properties such as odor and color, right, which we talked about, our permissible exposure limits of H2S. So we talked about where it comes from, exposures to that, okay? The employer also furnished the any PP that is necessary to protect workers from H2S hazards at no cost to the employee. Okay, that's in the PP standard. We know the employer has to provide for PP. That would also fall into that. Okay. 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 Okay, here is the meter, and this is going to kind of tie in to where we're going to kind of wrap it up here. The most common detection, and I was talking about the meter, so here we kind of go. The most common detection presence of H2S monitoring. It can be performed by a passive pump style monitor. Okay. This can be a pump that's used somebody above the space, the vault, the vessel that's standing there and it's taking the readings. Okay. And every 15 minutes is documenting where the air level is, where the CO is, where the H2S levels are. Okay. And if that signals, beeps, okay, and it's loud, lights here indicate we know we've got high PEL, immediately dangerous to life and health. So that's our line, our first line that it will indicate that we've got an issue, right? For continuous air monitoring, if it does go off, you want to exit the area, go get fresh air, okay? Here's just another style. There's several different styles, okay? This one here is a personal one. I don't know if any of you guys have ever worn one, a facility you've ever been to. I know you guys do tons of different things. Just kind of clips here. If you got to go onto a site, it'll clip onto you. And basically it's about that big, and it's just like a normal, regular 4 or 5 gas monitor, except it's something that you would clip on. You can go work in that environment. If something happens, CO, H2S levels go above where the level is, that will alarm. Okay, and remember, all these are set up to alarm at the exposure lower enough for you to get out. Okay. It's not an indication when it goes off, oh man, I'm in trouble like right now. And it can be scary, and they're very sensitive. Those can be, I've had them go off where I've been in different spaces or wherever I've been in steel mill, for instance, and a furnace. They're doing maintenance work and I come in to do an audit. They're required, some facilities require you to wear the personal one. Well, you go in and it could start alarming. Okay. You don't have to freak out. I mean, you see these lights and it starts, beeping and everything. You've got time to leave a space, okay, where there may be H2S present. Okay. What happens is when we don't have these safeguards, gas monitors, personal monitors, when we don't have the type of stuff in place or supplied air respirators where H2S is present, okay, that's when it becomes a major issue. Okay. That's where H2S is extremely, extremely dangerous. If you're in an IDLH atmosphere where H2S is present. Okay. Once again, here we go. Our air purifying, we may need to use that, your SCBAs, okay, where it's an air purifying system, okay? You're probably going to want to use, and I think that you would all agree, if I'm in an H2S environment and I have to work in it, and I know it's present, right? But we still have to do the job. Supplied air is what we're going to use, right? We're going to have supplied air, full face, the whole 9, okay? And a lot of times there has to be things conducted where the work needs to be done, or an inspection needs to be done, or architects, engineers need to go in there. They need to look at a specific piping or how, whatever, mechanically or however things work. Okay. So a safeguard is you're just not going to go in. Okay. Well, hey, you may need to have supplied air, but you can't just go in if you've not been fit tested and you have no idea how to use supplied air, right? Okay. Go ahead. Some rescue requirements on the rescue part. rescue training, practices, drills, never attempt a rescue you are not properly trained for, right? So that's where instinctively you're working with, your partner, and you're going to be involved in an issue where there's, potential H2S atmosphere, and they go in, something happens, and then you go in. A lot of times I know people say, well, that's human nature. It is. And that's a tough thing to make that decision. It really is. But when you're in an H2S environment, okay, you need to be trained if you are going to be someone who is going to do a rescue. But we're going to be prepared if we go into that space where there's H2S present, right? Because we're going to do a pre-evaluation. We're going to have trained folks. We're going to know about what H2S is, what a lot of the hazards are. We're going to know if we have that specific meter in place. We're going to do a pre-evaluation. Do our folks need to go in with fresh air? Okay. Do we need to have forced ventilation? So that's all going to be part of our training. Go ahead again. That might be it. Okay. So our knowledge check, okay? Hydrogen sulfide, colors flammable, extremely hazardous, gas with rotten egg smell. It occurs naturally in crude petroleum and natural gases. Okay. True. All right, go to the next one. Your personal air monitor is to be placed within 20 inches of your breathing zone. False, within 10 inches. That's why a lot of times they're hooked here. I've had guys that have put them on their hard hat, clipped it up here because it's easier for me to do whatever I need to do. It's going to be in the way. Okay, it needs to be in here, into your breathing area, which the best place is you clip it here or you clip it up high. Okay, just so it's in that breathing area. Okay, and that would be at the 10. Now, we talked about, remember the 10%, the 50, the 100, H2S, immediately dangerous to life and health, and IDLH at 100 parts per million. True, right? Because didn't we say the 10? Remember, we got a threshold, and how I went through the charting about your 50 to 100, your 200 to 500, how it just increases, okay? Okay. General industry peak is 50 ppms up to 10 minutes if no other exposure during the shift. Okay, go ahead. That would be true. That's in general industry standard. Okay, that would be your 1910. 1926 would be construction. It's a little different, but pretty much it's all the same. Okay, that it? Is that what we got? Hydrogen sulfide flammable is non-flammable. False. Remember we said that it is highly flammable, right? If you've got a spark, an ignition, things like that, a flame, okay. I believe that's it. Right? Like I said, I didn't really expand on more than nuts and bolts of it. That's why we kind of flew through some slides. But I kind of hope that, respirator wise, remember we're choosing the right one for the job. How are we going to know all that? We're going to have a written program, okay? We're going to have the right training, that you had a medical fit test. Then we actually had you fit tested on a half face, a full face, right? We're going to send you through the test, the qualitative, quantitative, right? It could be forced air from the machine, like a pulmonary function test. You breathe in, it's going to say if you are in the right range, that you can wear a fitted respirator. It could be where we use the smoke, right? We kind of use the smoke, it kind of goes around the seal, okay? If we taste it, if we smell it, okay, then we know we failed. You got to have the right size, okay? Things like that. Once we've determined that, then we have to have the specific, okay, the specific training done, the evaluations, and we have the right stuff as far as our manuals, that we know exactly this is what we work in our environment all the time. And a lot of times that's with specific companies. Okay. If you're somebody who's boiler repairs, you're in a boiler vessels and that's what you do all the time. Coal-fired power plants. Can you find H2S in there? Right? So if we're a contractor that works on boilers in a coal-fired power plant, we're probably going to have a good written program, and we're also going to have our employees that have been tested, whether it's fit, half mask, full mask. Once we know we've got a good fit on that, then we can move to, okay, do we need supplied air? Do we need specific filtration for particulates, for mist, vapors? Okay. So once we've got our medical eval, we've got a written program about it. We know the environment, what we're going to need, and that's all going to be in all of our training, right? So that's some of the stuff that we covered a little bit with the respirators, and I kind of think I went through. And you guys kind of have a somewhat familiar with the respirators and the types and what they do and everything. And H2S, I just really wanted to hit on that. We could have got on CO and everything else, but I don't want to bore you guys anymore. And that would have been an 8-hour training, and I need a drink. Guys, got anything? Yes. Yeah. If you're working even in a trench and excavation, believe it or not, you could be in a trench like this, right? Lower than air, right? It's heavier than air. So if I'm in a trench where there could be potential water, any type of sewage, anything, if you're in that working right here, right, it can affect you. So it has to be monitored, okay, to see where we're at. Are we above the 20.8? Are we at 25? Is it increasing? Right? That's our oxygen level. Okay. We don't want to go way below 19.5 below. We don't really want to go above the 20.8 on oxygen. That's what our monitor will monitor for, right? And then it's going to monitor for CO. It's going to in H2S, and it could be several different things. However, it's set up for. So if you know coming into it, this is the hazardous atmosphere that we may be working in, we're going to want to monitor that before we put our folks in there. Okay. And if we monitor it and it is high, second thing is, okay, we still have to do the work. We monitored it. We know the H2S level is high. What can we do in our evaluation to still complete the task, but keep our folks safe? Maybe supplied air, right? So there's a bunch of different things there. Okay, but medical evals that we can even wear them. Okay, training, okay, has to be done. So there's a lot of things you need to do in a respirator program that kind of ties over all the different H2S, the COs, and everything. Okay, your written program, your medical eval, and your fit testing. Okay, any other questions? No? Did I confuse you, or does it kind of make sense a little bit? I hope it made sense. If it did, they'll fire me. I won't be back here next time. All right. That's all I have. You guys are good. Appreciate it. Thanks.